second station person, it will do the assembly for all these ingredients. Combine with the first assembly. Combine, you get second layer assembly, maybe between here. Then after that, this worker combine first and layer, he will pass to the last one. Okay, pass to the last one, which is the pass to the last process that near to the kitchen, the last process of kitchen. The last person will use wrapper to wrap the food and send it to the counter. Okay, so this is the example of assembly chart. Okay, you can apply for, you can modify this one to any kind of products. Assembly chart usually was given to assembly station. Okay, if you have lots of station, then you make this one and then you monitor the progress of each station. Okay, if this one is robotic automation process, you can set the sensor over here, 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 and here. So you can monitor, control the process. Okay. Okay, so this one is just a discrimination or some this one. So apologize for those do not take Big Mac because of some reason. So again, you can change this one to other type of burger, but the concept is still there. Okay. All right. Now I'll give you another example. Let's say you want to manufacture a plastic part. Okay. So I think some of you haven't seen how people make plastic part, right? So you have one short cartoon here. So what does it make is that the plastic will squeeze and melt in this region. Okay, then you will force pump the molten plastic into the mold, injection mold here. So inject inside, the molten plastic will go into the hole here, and then a release of the component. So what does this example help you? Another document that you see when you go into manufacturing plant or manufacturing station, you will see the production floor manager. You will stick this one to each station, right? So you will give information like this: what part is going to assembly, what part is being made. So all the worker in the station there, they have one operation sheet like this. So the part name, the part number, usage, and assembly number. Then you will see that operator number, description, and department, tools used, what kind of tools used for that process, and the time. For example, the first one, you pour the plastic bit, and the tools you use is injection molding. The time will be 1 minute at that station. Okay, then you insert into mold, tools number, this one, because in factory you have lots of machine. So this is the machine number 076 for 2 minutes. After that, you check setting. You check setting of the machine. So there's a checklist on that station, and you're going to use machine number this. So there are 3 machines here. Specific machine that can run this operation for 20 minutes. After 20 minutes, you pass to the next station. You collect the part and lay flat. And this one is for finishing. Okay, for finishing, that process going to take 10 minutes. Then after that, you remove, deburr, and this one is a washer. You go to the pass washer, 15 minutes process to achieve the to make sure the mold is clean and the parts is being washed. Then after that, you have the deburr process. You soften or you make some sharp corner. You remove some sharp corner. This one is more on finishing. Another 10 minutes. So to make this part, you add all this time together. From here, add, you get the total number from the beginning of the process until the last station into packing. You know this process, this part need how many time. From here, you can calculate some of the variable costs from all this time lah, or from all this machine, right, and time. You can estimate the cost of these plastic tools. Okay. So any questions so far for operation sheet? But anyway, if you go to different factory, you will still see the same, not same lah, but similar format. If you work in the production floor or you work in the factory before, then you will see this one, right? Those with the ISO standard, they will brief you on the process. There will be a notice board at the front of the production floor. They will tell you what is the process. I will show you how plastic, okay. So I'll show you how people make plastic. And sorry, because in this video, the operator do not wear any PPE and it's not the standard occupation practice. So just take note. So if you operate on heavy machine, you should wear PPE and all this. Okay. However, what is important in this video is to have an idea how plastic part is being made, and try to see whether you can identify the process. Right. For example, the one that inside here. Okay. So you see the injection parts just now in the photo. So injection, and then there's a molding inside this chamber. So they put in the injector. Then you see it will stop for a while. So they'll calculate the time for each process. And this one is the finished products where they already injected the molten plastic there. So they will check, operator will check the quality. Okay. So this one is another side of the machine. So they remove the plastic from the mold, automatic from the mold, and they retrieve it from the machine, from the chamber. Okay. Okay, so this is another dimension. Again, when you go work in the factory, please wear PPE, personal protection equipment. This is not a good practice. Okay. Next, we focus more on the flowchart. Flowchart, inside flowchart, you will see there's lots of symbol there to represent the process. Okay. So this is the process flowchart for Apple product. Those fruit, I mean fruit product, not the iPhone. This one is the Apple, organic apple process. So if you look at this table, I believe you can observe some information there. First, you will see on the far left there, you will see a square, arrow, a half square, inverted, triangular. Each one of it have a different process. On the top there, it label. If you need operation, then it fall under circle. Then if you need to move to the next one, transparent, and then inspect. If you need to go to inspect, means from the first process you draw an arrow to the third one. Then after that you move back to transparent, transport. You transport to the next process. Then next process number 4 here will move to the last one. Last one will be storage. You send to storage, wait for the next process, then you will move to transport again, back to the operation, and operation back to the storeroom. Do something about, okay, step number 7, just a process, then back to storeroom. After storeroom, you will go back to operation again, and then back to, then go to the transport. Okay, so this is the way in some of the factory floor, they will use this process to train the operator. Okay, if you work in the automotive industry, especially in the assembly line, you will see this one in the computer and not on the hard copy. Okay, you see the flow chart in the flow, in the production flow. So all these process, there's a name there, and the time is given for each process, and the distance of travel also recorded. Total process will take about 450 minutes from the first process to the last process. And the total distance travel will be 190 feet. Okay, so from the flow chart, you can know what is the process, what is the flow in the process from the first process until last process. Okay, so what kind of question can come up from this table? We will give you a scenario. We will give you a scenario, and I will tell you a story from the first steps from the production floor until the last step, and I ask you to design a process flowchart. Are you able to do it? I give you an example already. So by using the same template, are you able to generate the flowchart for that particular scenario? So I'll give you a storyline. First step, the process go into what? Step 2 go to what? It pass to operator A, pass to operator B, stay there for how long? This operator have to send the product to process D at the distance of what? You need to fill in all this information and then put it as your answer. Any question on process flowchart?
So according to the question, Doctor, it will be subjective, right? Which means depends on our answer, and it's not like it's correct or wrong, right?
No, I'll give you a scenario that specifically mention the process. For example, let's say I tell you a story lah. Okay, so for the production floor of Apple, an Apple production, I give you a storyline lah. For example, so I give you one lengthy essay. You read and then you generate you from the essay itself you generate something like this as your answer. So for example, I use this chart to tell you a story lah. So in the Apple production floor, the workers collect the apple from farm, and the apple was collected using robotic arm, and the apple was traveled to a truck. So you generate the first process. So by using the same template, you mark the red color for the first process, and you write unload apple from truck. So this one, how you write this one, I will put in the story. As the robot reach production floor, the robot will pour the apple from the robot truck or automate truck. So this one you write lah, unload apple from truck. And in the story, I will tell you the distance travel from the farm to the first process of the production floor will be maybe 1 hour. But when the robot load the apple into the load the apple from truck into the first container, the whole process going to take about 20 minutes. So you fill in the information using this template. Then I will continue with the story. I will tell you Once the apple was collected in a beam in the first station, the beam will send to the station number 2, where station number 2, the worker will inspect the apple manually. So each worker will inspect the worker at station number 2. So you write, okay, you write number 2. So number 2, you highlight transport. You will transport to that station, how long? Then what to do? Okay, so I tell you, okay, from first station to second station is 100 feet. So you write the second one. You mark the second arrow because second arrow is using transport. Okay, you mark the red color arrow and you draw a line from the first one to second one. Then I continue to tell you what happened in station 2. So at station 2, the worker will weigh the apple, you will inspect the apple, and they will sort out the apples. Those rotten ones, they will throw into recycle bin for organic soil or fertilizer process. So this is the second station. What happened in the second station? And the process will take about 30 minutes. So you fill in 30 minutes, so on and so on. So it's not subjective question.
Excuse me, sir.
Yes.
Sir, what's written beside the storage? I couldn't see clearly.
Again, what is your question?
Yes, sir.
What is your question? Can you repeat? Just now your mic is a little bit high pitch, a bit. I'm not able to hear clearly. Can you repeat your question?
Sir, the one on the steps.
Mm-hmm. Oh, this one. This one is it?
No, the steps.
This one.
The operation transport.
Oh, you mean this one? The shape is it? The shape. Okay.
What is written beside the storage?
Okay. Now, on the process chart, we will use symbol to represent the process. So on the second column there, on the top of the column, the first column, the first column is circle, right? Do you see the circle? So the circle represent operation, means some activity in the production floor. The first circle, the circle item, the circle shape means operation. Then the second one is arrow. Arrow shape, the second column, arrow shape means you transport. You transport it to somewhere. Then the third shape is square. The square is inspection. Square is inspection. Then the half square there, the half shape, the half square shape is delay. Means you stop the process and you delay it a little bit. For example, you need to frozen, or you need to not frozen. You need to For example, frozen. You need to marinate the. For example, you need to marinate the product, or you need to cool down the product. So it means delay. You need to wait for how long? You need to do curing, for example. Right? You do plastic glove. You need curing process. So you need the delay. Then the last one, the inverted triangular, is storage. Do you see the idea just now? Do I explain your question? Do I answer your question just now?
Yes, sir.
Okay, good. So basically, for the process chart, we will use a lot of symbol to represent the process. So all this standardized. So if this question come out, this question come out, I will in the question I will tell you use what shape to represent what. I will tell you a circle represent what, arrow represent what, inverted represent what. So this one is just a sample. So I tell you to use what symbol for that what process. Okay, maybe I tell you I put a star there. A star represents something else. A star means maybe I put in one special process there. Then inside your table, I expect to see star there. And then you link each process to another process. For example, process 1 to 2, you see that I highlight the red color. The red highlight the red color means that particular process. What is that? For example, the first one. The first one is operation. Okay, that's why you highlight with the red color. In exam, you highlight with your ball pen. You highlight the shape with the ball pen. Then, how you link the first process to the second one? You use line. There's a line there. So that's why you see there's a circle and the arrow, and then connected with the line. Then continue with the third one. The third one is wait, inspect, and sort. This one under inspection. So that's why you highlight the square box, and then you continue using the line to connect from the second process to the third one, and so on. Okay. Any more question for this flowchart? Anyone of you still don't know how to convert an essay description to this table?
Other than that, the description, time and distance only. Any other details, Doctor, will be there?
Normally it's this one. You just build a table with all the information given. If the essay give you, the essay will mention time and distance. So basically, I'll just, what we want to assess you is that are you able to build a table from the information, from the whole verbal description? Meaning we want to train you as an engineer. Are you able to tell the production flow with diagram? So this is how you do analysis as an engineer when you work in production flow. This is how you monitor the process. Okay. Any more question before we move? Next slides.
No questions, sir.
Good, huh? All right. Excellent. So I just show you one video just in case you didn't know how people process apple. All right. You can lower your. Sorry, too loud.
You can't eat apples right off the tree. You should wash them first. But we package apples in order to put them into consumer packages and to protect them. So we take them out of a bin, we put them in a cardboard box, and that gives them some protection for transportation. We have between 20 and 25 varieties of apples. We have Macintosh, Ida Red, Honeycrisp, Ambrosia, Gala, Crispin, and Golden, some of the varieties that we handle here. So we do about 5 different indices on the fruit to take a look at them and then determine from that when to pick. So we have a lot of samples come in prior to harvest, and then we determine from them when the best time to pick the fruit is so that it eats well for the consumer and will store well. We use water to transport apples to make it easy. It's gentle on the fruit. So in doing that, we take the natural bloom or wax off of an apple, and then we need to replace that. So when we wash them and polish them, we put a wax back on them to protect them, to prevent desiccation in the stores and give them longer shelf life. We use technology today quite extensively on the line. So as the apples come over the sorter, it knows where it is on it. It measures it by weight, it measures it by optics, by size, measures the color on the fruit, so how red it is or how yellow it is, and it also takes a look at it and determines if it has defects or it doesn't have defects, and then sorts them according to that and puts them where we allocate it, either for fruit to be sorted to process or fruit to be sorted to the fresh market to go into a bag or a tray. Mostly working with scales is pretty simple. I mean, we've weighed apples since the early 1900s, but the technology today uses color cameras and infrared cameras. It takes about 20 pictures per fruit and then evaluates those pictures against a color standard or a defect standard. So it takes all of those pictures as it rolls the fruit underneath the camera, and then from there it sorts the fruit into the parameters that you're looking for. Apples are packed into cardboard boxes to protect them. So it allows us to protect them. It also gives us a facility to put a marking on the fruit to know where what variety it is and where it came from and what size it is. We also today put a marking on the side of the box with a barcode that identifies the farm that it came from and the date it was packed, so that we're able to provide traceability as to where we received the fruit from and where we send it to. The key to making them stay fresh is to pick them at the right time, and then we put them into storage rooms where we control the atmosphere. An apple breathes carbon dioxide out and oxygen in. So we reduce the oxygen level in a room to suppress the respiration of the fruit, basically put them to sleep, and then to keep them that way until we're ready to pack them. And then we would put oxygen back in the room by just putting air in it, bring the apples back awake, and then we pack them and send them to the grocery store.
Okay, so this is a example of process flow. Okay, next one I will show you. This is you can see the detail on my slides later, right? But what is important for this slide is that you can identify the different shape that you use for different process. Okay. Later you can zoom in out in my slides later. And if you already download the tutorial question, you should be able to see very clearly in the tutorial handouts that I put in the Teams. All right, you should be able to see this one clearly. All right. So I want you to use the Microsoft Visual just to build this flowchart, process flowchart as a homework. So, but you don't need to pass to me. You don't need to pass back to me. Just this one as your homework. Okay. Later I'll show you the Microsoft Visual, how you draw, how do you visual to create this one. Again, this one is your homework. You don't need to pass it back to me. It's just to strengthen your learning experience. All right, there is a flowchart, and how do you convert from your scratch to using computer software to draw all this. Okay. Again, you need your Microsoft 365 account, or you should using your Scholar account. Scholar account. Later I will show you after this. Okay, I'm going to switch to another screen, and yeah, I will show you. Okay, so you see some after you log in your Microsoft 365, you go to Microsoft Visual, you will enter into something like this. You will see something later. I will show you. Okay. Okay, maybe I will stop here. Okay, I'll stop here. Let me end the recording.